So for the warm-up, we're going to review slope, all right? One of the first things you're going to have to do is you're going to have to find the slope given a drawing, all right? So one of the things that, depending on the worksheet or the assignment, sometimes they'll give you dots, sometimes they won't. But you want to make sure that you choose dots that are located clearly at the intersections of the grid, okay? So they've chosen these for me, but I just want to make sure that I mark that. If I count to find slope, my rise is 1, 2, 3, my run is 2. The slope goes uphill, so it would be positive 2/3. And also, just to reinforce, slope is signified by like a little special cursive M, okay? All right, for number 2, we're going to do the same thing. We're going to pick 2 points that are located at the corner of the grids. This is a negative slope. I went down 1 and over 3. And I'm done with that. Okay. Then we get to word problems. And if we just scan the word problem real quickly, they ask you for the rate at which he bikes. Anytime we talk about rate, just going to put this here real quickly, rate is oftentimes equal to slope, especially when we're in a slope unit, whenever they talk about rate of change or rate of biking. So given a word problem, you should be able to set up 2 ordered pairs. So for instance, 2 is the second hour, and he goes 40 kilometers. On his 5th hour, he's gone 100 kilometers. Okay? As soon as we say slope, 2 pairs, we can go ahead and set up our outline slope formula. And remember, I like to use these parentheses. That way, if there's negatives, there's no issue with that. We start with y2 and we go to y1, so we're going in this direction always. So 100 minus 40 over 5 minus 2. All right, so this reduces up top to 60, and in the bottom is 3, which is 20 per 1. So this would be 20 kilometers per hour. That is his rate. Right? All review. I'm hoping at this point this is old hat for you, that when you recognize the problem, you know how to do the math behind it. So we've also been introduced to, we've reviewed it but not in formal notes, slope-intercept form. Okay? Slope-intercept form is called that because you get 2 things from the form. You get M, which is going to be your slope, and you get B, which is going to be your y-intercept. Okay? Your y-intercept always goes on the y-axis. Okay? So this is a point on the y-axis. Right? Now, one thing I want to know, I'm going to do this right here in the beginning, is that sometimes you're going to get a problem like y is equal to negative x. Okay? This is still slope-intercept form. There's just some things that are understood for being there. Okay? The first thing that's understood is that the number in front of x is a negative 1. The second thing that's understood is that there is a plus 0 at the end. So if I kind of clean that up, I think it's evident to see that here's your mx plus b form with a bunch of understood numbers that we can add in. Right? So in this case, m would be negative 1 over 1. We always write slope as a fraction. And our y-intercept would be 0. So that means it goes through the origin, or the middle of the graph where the 2 axes meet. All right, this is a special case. It will come up. Anytime you have an x and a y, and we're talking about lines, you can always go to slope-intercept form. All right, so the first skill with slope-intercept form is figuring out, looking at a picture, what is the slope and what is the y-intercept. So they want to know what is m and what is the y-intercept going to be in the picture. Okay, so my y-intercept on my y-axis is right here. Make sure you focus on the y-axis, which is 2. My slope, now since I've already picked that point, I can come over here and pick this point. My slope in this case is a rise of 2 and a run of 3. Then they want you to write the equation in slope-intercept form. So y is equal to m, which is 2/3, the variable x, and then this is a positive 2 at the end. Okay, the y-intercept and the letter b are interchangeable. And all we do is we plug them right in to our formula. Okay. Same thing here. Notice this crosses at 3. My slope is clearly downhill. So here are my 2 points, down 1 over 1, 2, 3, 4. So my equation is y is equal to negative 1/4 x plus 3. All right, perfect. Now, one thing we want to keep in mind is special case lines. Anytime we talk about graphing lines in slope-intercept form, most textbooks are going to try to trick you and throw in some special case lines. Okay? So this is an example of my special case. The two special cases are either vertical lines or horizontal lines. Okay? In this case, this is a horizontal line. So my special case comes from the acronym YO. Even if they ask for slope-intercept form, we're going to follow the procedures we did for YO. YO is y equal to some number, and that number happens to be the number 3. Notice there's no mx plus b, it's just y equals 3 because this is the special case. So it's almost like we have to ask ourselves, am I dealing with special case first? If not, go to y equals mx plus b. That's a big theme for today. Now, I'm going to do the you do section just because I think it's quick and it's easy. If I take a look, this is not a special case line. So I can go right to, okay, here is my b point, which is negative 2. My slope is obviously negative. Here is another point located on the line at the grid intersection. My slope is down 1 over 3. So my equation is y is equal to negative 1/3 x minus 2. Right? So step 1 is simply looking at a graph, finding m and b, and then plugging it into a formula. All right, so we're kind of counting and then using those two counts to put them into the formula. Now, the next section, all right, which is where we're going to get to down here, is taking an equation given to you of a line, putting it into slope-intercept form, and then identifying the slope and the y-intercept. Okay? So anytime you're given these directions, my hope is that when it says slope-intercept, you would write this down, and you would say, oh, that's right, I have to get y by itself. That's my goal. Right? So what I'm going to do is I'm going to push this up, and I'm going to tell you there's 4 main parts to accomplishing what you're being asked to in example 2. Okay? Now, I'll go through this quickly, and then I'm going to post a screenshot of just this. So let me actually do that right now in the Google Classroom. So Shift Apple 4. I'm going to take a photo of this. Okay? As soon as I'm done with the lesson, I'm going to post it back into Google Classroom. But the first thing is, read through the equation. Do you have x and y variables? If you don't have both of those, then it's going to be a special case, hux or voy. I'm sorry, hoy or vux. I said that incorrectly. So we're going to go right to those special case rules. If you have both variables, x and y, so take a look up here. I have an x and I have a y. I have an x and I have a y. Then we're going to follow the rest of the steps. We're going to move the x term and the number to the opposite side of the y term. We're going to divide every single person, every term by the coefficient in front of y and reduce. Then we can determine m and b, and we can graph them or answer questions or whatever the case that we have to do. Okay? So I'm going to go up and do these, and then again, you can copy this down in a little bit here. So up here, Yes,
Since
Cam.
that's like a lot of writing, would I be able to just take a picture of it? Because like
Yeah, go ahead.
it's kind of
Take a picture
because
right
like
now.
it's gonna look like a whole mess on my phone because I'm doing it on my phone, taking the notes.
Yep.
And
If any of you want to take a quick screenshot of what's on the iPad, that's fine too. Go ahead.
and if I don't write it down on the thing, will I lose points on my notes? Like,
Just put a note in your notes to say see additional screenshot and then submit it with your notes. Like see screenshot. And then when you
okay.
submit the notes, just make sure you drag that photo into Google Classroom also. Okay?
All right.
All right, so step 1 here says, do you have X and Y? Yes, this is not special case. Step 2 says, move the X and the number to the opposite of Y. Well, here's my wall. It looks to me like the X term and the number are already in the opposite room of Y. So now I'm going to divide everybody by 2. All right, so I'm right here at step 3 down here at the bottom. Okay. There's a little bit of a glare, so let me try to move this down so it's not so bright into this. There we go. That's better. Okay. Divide everybody by 2. This is going to cancel to leave me with Y. 4 over 2 becomes 2x. Negative 10 over 2 is negative 5. And I can actually put the 2 over 1. Okay. So then here, my slope is 2 over 1. And my y-intercept is negative 5. When I look at the next problem, step 1 says, are there x and y variables? Yes, there are. This is not a special case line. Awesome. Next says, to move the x terms and the number terms in the opposite room as the y term. So I'm going to move this to the other side. So negative 14y is equal to negative 7x plus 28. Now notice how I kind of switched things up on you. I put the x term first. Why? Just because I think it looks better to be closer to mx plus b. So I moved it to the other side, and instead of putting it at the end, I put it in front. Now I'm going to divide everybody by negative 14. The number in front of y. Y is equal to 1/2 x. This reduces to negative 2. Right? So in your calculator, you would just go into your calculator, you would use that little button, you would put in negative 7, negative 14, you would hit enter, and it would give you back the 1/2. Right, so over here, slope is 1/2, and my y-intercept is negative 2. Okay. So in this section, I would say this is worrying about the algebra and answering questions about slope and y-intercept. The final skill that we're going to do in the notes today is to take these equations and graph them, all right? But the graphing requires you to be able to know what the y-intercept is and what the slope is. So if I look here, y equals, okay, I'm going to write this up top one time instead of every time on there. mx plus b is my form, or I could use Vux, or I could be using Hoy. So it's one of these 3. I'm going to come in here, and I'm going to say, okay, well this matches directly. I don't need to do any algebra. I don't need to do any work. I need to see that m is negative 2 over 1. Slope is always a fraction. And then my y-intercept is 1. So I go on my y-axis, I plot the 1. I go down 2 over 1. If I want to do it again, I can. And then I can connect my line. Okay? If I were your teacher, which I am your teacher, and this was a regular year and I were grading things more closely, I would say, do you have this point correct? Did you count down 2 and go over 1 to find this point? That's what I'm looking for. Now in part B, we ask ourselves the questions from the other side. So I just want to return to those for 1 second right here. Are there x and y variables? Yes, there's x and y variables. Then this is going to be slope-intercept form. So I need to remember that there is a plus 0 at the end that is understood to be there if it isn't located there. Now I know that my slope is negative 2/3 My y-intercept is 0, which means it crosses right here at this center dot. Let me move that up now. Down 2 over 3, I have my negative slope, and I can connect to draw my line. Now, notice in letter C, I have it circled. Do I have x and y variables? Absolutely. So this is not a special case line. Do I have the y variable by itself and x and a number on the other side? Yes. Awesome. No algebra needed to do that. But what I do need to do is get y by itself. So I'm actually going to be entering in down here at, on the other sheet, what was step 3. So I get y is equal to 3x minus 4. So m is 3 over 1. And my y-intercept is going to be negative 4. 1, 2, 3, 4. Count up 3, 1, 2, 3 over 1. Connect. And we're good. All right, moving to part D. Do I have an x and y variable? Yes, I do. Do I have y by itself? No. So here's my wall. I'm going to add 6 to move it to the other side. Now I have y is equal to 1/2 x plus 6. That is slope-intercept form. M is 1/2. My y-intercept is 6. 1, 2, 3, 4, 5, 6. Key point, y-intercept, up 1, count, over 2, up 1, over 2. This case I decided to make an extra dot, draw my line. Okay. Now we're going to get into a little bit more trickier problems. Draw on the wall. Obviously, I have an x and a y term. This is not a special case line. Awesome. But now I need to do some work to get y by itself. So I'm going to move the 6x to the other side. I'm going to put the 6x first so it looks like the form I'm going for. Remember, the form I'm going for is right up here, y equals mx plus b. Divide everybody by 2. Go down 4. So again, m is 3 over 1. My y-intercept is negative 4. 1, 2, 3, 4. Slope up 3, 1, 2, 3 over 1. All of the ones I'm doing in purple are mimicking that entire process of having to solve for y. It wasn't given to me right from the beginning, and it wasn't a special case line. Last one. Do I have an x and y variable? Yes. Do I have y by itself? No. But in this one, I want you to think a little bit differently. I could move x to the other side and do a lot of work. But what if I moved y to the other side and moved phi back over here? So let me show you what that looks like. X minus 5 is equal to positive y. I was able to solve this equation very easily just by moving people left and right without any division. I then could rewrite this and say, well, we could put y on the left, and I could say x minus 5 on the right. M is 1 over 1. There's a 1 understood to be there. And my y-intercept is going to be negative 5. 1, 2, 3, 4, 5. Up 1 over 1, up 1 over 1. And I'm done.